We have been discussing about drawing of phasor diagrams of salient pole synchronous machines under different conditions. Why it is important? It is important because in case of salient pole machines, it is because IA is to be decomposed into two components ID, IQ. Machine may operate either as a generator or as a motor, or it may be also operating either at leading power factor or lagging power factor, and students often make mistake in drawing the correct phasor diagram. Unless you draw the correct phasor diagram, because phasor diagram drawing will help you to solve the problems very quickly. We will give you some example, typical examples, not all, but you go through books where worked out examples are also there on salient pole machines, but do it independently on your own. So, last time I told you how to draw phasor diagram of a synchronous generator at leading lagging power factor, how to draw phasor diagram of a synchronous motor at leading lagging power factor. There are several things after drawing the phasor diagram you can verify that everything is in correctly drawn. For example, synchronous motor leading power factor somebody has drawn like this. Is it correct? I find it is correct because V is ahead of EF, that is the first thing, motor mode. V cannot be here out of question. Then you have been asked to draw at leading power factor. Is it at leading power factor? Yes, it is, because IA leads V as well as EF. Okay? And everything is in place. And also I know that when a synchronous motor operates at leading power factor, it is overexcited. Does this phasor diagram confirms this? Yes, it confirms that, because length of EF is greater than V, that is all. And so, this is the thing. Now, I will draw another two interesting cases of drawing phasor diagram. For example, I say that a salient pole machine, salient pole generator mode, generator connected to bus. All phasor diagrams I am generally referring to connected to bus. Although it does not mean that if it is in isolated operation, this phasor diagram is wrong. It is not like that, because if it is connected to bus, this length of V in this phasor diagram gets fixed. Other length of the phasors may change, but length of V will remain same, that is what it is. Otherwise, it is also true for isolated operation of generator. This phasor diagram is true, okay. This you must understand. Now, suppose a salient pole generator connected to infinite bus. Infinite bus or also isolated, it may operate, I hope so. Let us see what happens. And suppose but the condition I put that the field current of the generator, field current IF is 0, no excitation. First of all, with no excitation, that is a synchronous machine is there, it is connected to bus here, root 3 V line to line voltage, it is there, and the alternator field current I have made it 0, IF, you recall IF is 0, that is no excitation. First of all, will it still operate steadily? Yes, it can operate if it is a salient pole machine, because in salient pole machine the power term, you recall there is one term of power which was equal to this What is V? V is the terminal voltage. There is no EF here. So, that other term, sin delta term, that coefficient has become 0, that was EF V by x d, if you recall. But since IF is 0, means EF is 0, that is all. So, this term is 0 in this case. However, this term will be there, therefore, a salient pole synchronous machine is capable of delivering or absorbing power depending upon whether it is operating as a generator or motor mode. So, generator connected to infinite bus with field current 0, which implies that EF is 0, can still operate, can still deliver some power to the bus, that is the important thing. Now, in this case, how to draw the phasor diagram? Listen carefully. So, it is generator mode. So, I will use this one, the relation I will use is EF. I will start with perhaps V plus J I D x d plus J I q x q, and this EF is 0, is not EF is 0. So, this must add up to 0, that is the thing. Now, how to draw the phasor diagram of this? The first step, as usual, is assume that this is your q axis. I assume that, okay, and this is of course will be at right angles. This will be your d axis. This I can do, no problem. So, q axis d axis is defined. We know EF has to lie on the q axis, but EF is now 0, or for that matter what I am telling, suppose IF is very close to 0, then EF will lie with a small length or vanishingly small length. That is how you try to convince yourself. EF 0 means EF is vanishingly small, but its direction will be along q axis, is not, that is the thing. So, although EF is 0 means this point, okay, you imagine absolutely very small IF exists, okay, EF will be along this line, nothing doing. So, EF is 0, but V is finite, it is connected to bus, terminal voltage is there, you have synchronized the machine, then perhaps brought the field current gradually to 0 of this machine. So, that only salient power due to saliency term is present. V is finite, having large voltage like that. However, EF is 0. So, the next thing I ask is that, is the machine, and no power factor is given in this case, what I am telling, field current 0, terminal voltage is finite. Then I have to apply my my knowledge about the synchronous motor in this way, that this EF is 0, IF is 0, V is finite. Therefore, the machine must be, this generator must be operating under excited condition, because EF is vanishingly small, V is finite. So, this conclusion I have to draw. After knowing this, it is generator mode. So, generator, this generator must operate under excited, as under excited. Why under excited? Because EF, which is 0, is less than V, length of V, that is the reason. And I know if a generator is under excited, then it must be delivering leading power factor current. Then generator must operate at leading power factor, nothing doing. Under excited synchronous generator, leading power factor. How do I know it is under excited? I know because EF is 0 and V is finite connected to bus. So, this thing must happen. Okay. So, this is the thing. So, I now know that armature current will be leading power factor. So, let me draw the armature current. Suppose the armature current is here, IA. EF is not there, but vanishingly small along this line, that is there 0 collapse. Then I know where is my ID and IQ, that is this one is your ID and this one is your IQ, this I know. Second property I will utilize, that it is a salient pole generator. In salient pole, in generator operation of synchronous machine, EF will be ahead of V. EF is in which direction? 0, small along this. So, V must be behind that, V must be in this quadrant. It cannot be here in any case, because then V will be ahead of EF. EF equal to 0 may disturb you, but what I am telling, imagine that EF, okay, it is field current is vanishingly small, 0, very close to 0. So, EF is there along Q then. Therefore, the question is the V must lie here. This must be your V, nothing doing. So, it satisfies everything. It is generator mode, V is behind EF. Where is EF? Very small, 0 here along Q axis, and this angle I will still call delta. I can. IF equal to 0 is a special case of excitation. So, this will be your VA. Then in generator I will add to the moment I get VA and I got IA, this must be your power factor angle at which the machine must operate, and this is ID. So, V plus J ID XD. This is the ID direction is like this, as you can see ID. So, J ID XD is this way, is not? So, it will be J ID XD. Then J IQ XQ. IQ is this way. So, J IQ XQ is to the left. Therefore, this is J IQ XQ. So, V plus J ID XD plus J IQ XQ must end up at this point O, because EF has to be 0. That is, I have not drawn like this, this was V. I cannot stop IDXD drawing up to this point, because then this and this J IQ XQ will give you some finite EF, but that EF has to be made 0. It can do so only when if it comes up to the D axis, then J IQ XQ add up, everything is in place, theta, delta, and this angle is psi, the internal power factor angle psi. Therefore, a salient pole generator, even with its field current 0 connected to the bus can pump power into the bus at some specified angle delta, but at leading power factor. It cannot be this salient pole generator cannot operate under lagging power factor. Why? Because EF is 0, which is much less than the length of V, therefore, it is under excited machine. So, this is the phasor diagram of a synchronous generator connected to infinite bus. Over. Okay. Now, similarly, let us draw the phasor diagram of salient pole synchronous motor connected to bus and field current brought to 0. Okay. So, salient pole synchronous motor, now it is operating in motor mode. Connected to bus, and with IF equal to 0, which implies that EF is equal to 0, is not. So, this is the situation. Now, in this case, salient pole synchronous motor connected to bus with field current equal to 0, I have to draw the phasor diagram. So, what is the thing? Draw the phasor diagram. So, once again I go by that rule. I first draw the q axis, that is I mark it as q axis, that is all. Then your d axis will be at right angles, draw it. In case of motor, I told you it is always better to use this formula, because then you have additions B plus J I D x d plus J I q x q. Okay. This is the thing we will be using, because then addition rules will be applied. But in this case EF equal to 0, because IF equal to 0. So, B plus IDXD plus IQ XQ must add up to 0, IQ XQ. So, where to start? B is finite, because machine is connected to the bus. B is the terminal voltage per phase, and that is finite. EF is 0. Therefore, a synchronous motor connected to bus with EF equal to 0, at what power factor it will operate? Under excited synchronous motor. So, the machine must be under excited. Why? Because EF, which is equal to 0, is less than V, V is finite. Connected to bus, it has got a definite voltage. So, it must be under excited. If it is under excited, then armature current must lag the voltage. So, EF is vanishingly small, but along q axis. So, it is here a small length, vanishingly small length like this EF. Therefore, your armature current may be somewhere here. So, EF is this is the line along which EF lies. So, armature current lags that, and also it is a motor mode. In motor mode, V EF will be for motor, EF will be behind V. So, EF is here. So, V can it be here? No, nothing doing it cannot be, because in a motor mode V will be always behind EF. EF is along this line, which in this case is vanishingly small, but nonetheless it is along Q, and V cannot be here. Then it would have been generator. So, V must be in this axis. So, your V will be in this quadrant, and before that, of course, the moment I got IA, I will say this is my ID and this is my IQ. This is IA, this length is IA, IQ. This is the internal power factor angle psi, because this thing, and your V will be in this line. So, let us draw V. Suppose V is here, then this is the power factor angle theta, angle between terminal voltage and armature current is theta. Then I have to add to this is 0, EF is not there. So, 0 is equal to this. So, V plus J I D x d. So, I d is along this I d, if it is like this I d, then J I d x d will be like that, like this. This is I d. So, J I d x d. So, this is Q axis, this is E f, this is armature current here, armature current here, and under excited means lagging power factor. So, Q I d I q you get, then in case of motor V should be ahead of EF. These same arguments I am repeating, because I am facing some problem. So, this is the thing I d x d. Now, to this V you have to add J I d x d. Why it is giving like this? I d J I d x d will be like this. I d is this way, V it will be E f is 0, no, lagging. So, J I d x d, let me draw whatever it is giving, then we will conclude. J I d x d is like this, V plus J I d x d, J I q x q is like that, and then this will be your E f. No, it cannot be. So, it must be O, J I d x d and J I q x q. Is not? This will be the thing. I will redraw it nicely. See, it is motor mode. So, what you do with excitation 0. Okay. So, I draw q axis, please let me be with me. So, this is d axis and your field current will be 0, it will be somewhere, and it is definitely E f equal to 0 and V finite, and it is motor mode. These are the informations you need, motor mode. So, the machine is under excited. Under excited synchronous motor always draws lagging current. Okay? It will draw lagging current. So, this EF is here. So, V will be here along this line. This will be your V, and it is lagging current. So, suppose let me draw this lagging current as like this here. IA. So, this will be your ID, this will be your IQ, so V plus J ID X D, ID is this way, it will be, it was wrong earlier, it will be like this J ID X Q ID, and this one, this vertical line IQ, so J IQ X Q. So, this will be the thing J I D X D plus J I Q X Q. That is, in other words, what I am telling, it is better to learn from mistake. When I drew like this, IA I drew here, same argument, leading power factor, I thought it may be here, it may be there, with respect to V, it may be here also, I do not know, but I drew like this leading power factor theta. If you draw like that, then your ID and IQ becomes this way, and your V has to be ahead of EF. So, V you draw, but then you note that if it is to be like this, then to V J ID X D will go like this, and J IQ XQ will be going like this, and this point must be at the origin, so that your EF is 0 and it is violated. Situation cannot be like this. Okay, lagging power factor, that is, this is theta, IA has to be in this quadrant, so that ID is this way, IQ is this way, then V plus J ID X D. So, ID was here like this, J ID X D is like this, and IQ of course was vertical IQ. So, J IQ X Q will be like that, and you will get the Phasor diagram of many types of machine in this way. So, with this so salient pole synchronous machines can operate with exciting current IF equal to 0. Suppose I say that this is the last thing, one example I am giving. Suppose I say a salient pole generator connected to bus operates at maximum power condition, with IF equal to 0. Then what do I do? Oh, expression for power in such case is half 1 by x q minus 1 by x d sin 2 delta. So, in this case, for P max, delta must be 45 degree. understood, and I can draw the phasor diagram of the machine, and if I say x d equal to 8 ohm, x q is equal to 4 ohm, V line to line is 400 volt, 400 volt. Draw the phasor diagram, draw the phasor diagram, and calculate armature current and power factor, armature current and power factor. This you try to solve drawing the phasor diagram on your own, giving proper argument, that is the more important issue. The things I have used is, okay, synchronous motor or generator, I must see whether it is under excited, over excited, then I will draw the armature current. First I fixed up of course Q and D axis, then I D I Q you find out, and then complete the phasor diagram. And once, and in case of with excitation 0, it will be a single triangle of this kind. In case of generator mode, it will be a single triangle, of which this side is given, this side I will be able to calculate. IDIQ, if you know, armature current will be under root IQ square plus ID square. So, this synchronous motor with field current 0 we were discussing, and the interesting thing I would like to tell about the drawing of the phasor diagram, which very quickly let me do it, so that we can see this is Q, this is D. But in case of motor, I was telling that I will start with EF. This was the thing you must be very careful about, IA plus J I D X D plus J I Q X Q. Most probably while adding I started with EF and that is the confusion. So, this EF is 0 plus J I D X D plus J I Q X Q must be. So, this is salient pole motor, connected to bus, and with IF equal to 0. So, field current is 0, it is here and it is under excited. Therefore, your it must be lagging power factor. These are the logic you put properly, lagging power factor. So, your IA will be here, this is correct IA, and then IA, and this is your ID, and this is your JIQ. It is like this, and EF is 0. So, 0 plus you know, to this 0 you have to add ID XD. So, EF plus J ID XD and J IQ XQ. Everything is consistent, ID, J IQ XQ, and this is your V, and this will be your theta and this will be your delta. This is the most correct one, and XD XQ. So, give proper argument and write correct equations. So, EF 0 plus IDXD plus JIQXQ gives you V, lagging power factor under excited. Okay, thank you.